This is problem number 24 from the 2004 AMC8. And it's a very good example of utilizing area to find important parts of a shape. In this case, it's going to be a parallelogram. It asks you at the end to find length of D, and it says that you have a rectangle and a parallelogram. And then it gives you a bunch of information about these side lengths of the rectangle. And then that tells you also that D is actually at a right angle to FG and HE, which means it's what's called an altitude of a parallelogram. If we were to make this kind of look a little bit more like we normally look at parallelograms, it would look like this, and we'd be trying to find this length, and or D actually. And so in doing this, we can use area to find D, because the area of this thing is going to be whatever the base is times D, the area of the parallelogram. Well, we know what the base is because this triangle is a 3, 4, 5 right triangle. So we know the base is 5, so we can say 5 times D equals the area. So we need to discover a way to find the area. Well, it turns out that finding the area is pretty easy, because it is a rectangle that is a 10 by 8 rectangle, and then you just subtract away these triangles on the corner. This is a 6 by 5 right triangle, and so that's going to be 1/2 times 5 times 6, which is 15. Same thing up here, except that it's 12 times 1/2, which is 6. That triangle is exactly the same, so that's 15. This one's 6. Add all those up, you get 42. And so that means the area of the parallelogram is 38, because the area of the rectangle is 8. Subtract away each little triangle, which is 42, and you get 38. So we know 5D equals 38, so we divide both sides by 5, and it's easy to see that 38 divided by 5 is 7.6, which is the correct answer. And that really is the best way to do it. There's not a way to utilize Pythagorean theorem other than using it to find this length. And so that really is the best way of finding that solution.